welcome to another video. This time we're gonna make a node system with Unity's default API. We don't have to import any kind of external package. That's not what we're gonna do. As long as we are working about 18.1, Unity is providing what it is providing to shader graph and the VFX graph by default, which is something called GraphView API. And with using the GraphView API, we're gonna achieve creating a node system. But before we begin to the tutorial, I would like to mention about a few concepts. First of all, in a node, there is something called edge. So edge is basically the connection between two nodes. It's called in the Unity's GraphView system. Another thing to notice is a few other concepts. So the nodes, GraphView, and few other terms such as there will be grid background or sticky nodes. Most of those stuff is provided by the API by default. So you don't have to write any kind of mouse drag to move the node or like to make a connection, draw a line render or something. You don't have to do anything like that. It's provided by default, it's embedded in the engine, and it is using this namespace. So with that knowledge, we can begin, but I want to make sure that you understand in a node there are two parts. So in a node, there's an input container at the left-hand side and an output container in the right-hand side. So we're going to add branches to our dialog system, to one of the dialog node, to the output container, and for other dialog nodes to connect to that one, if we want to make merge and stuff, we're going to make an input port. Yeah, this is another concept that I wanted to mention actually. There is something called port, which means this is the connection thing that you can do. So you will have two ports and you basically achieve a connection when you connect them. And this connection is named as edge in API. So this is the old briefing actually. There's nothing else to mention. With this knowledge, we can begin the tutorial. Let's jump and see what is it like. We're gonna start by creating three major classes: dialog graph, dialog graph view, and dialog node. All those classes gonna inherit from Unity's embedded GraphView API. Dialog GraphView class will be inherited from GraphView class. Dialog graph will be inherited from editor window class. And dialog node will be inherited from node class. Cool. Let's start by storing some information in the dialog node class. Let's add a GUID. That might look confusing, but you can think of it as a unique ID that we will pass for each one of the nodes to distinguish those nodes between each other. Next, we're gonna need the actual dialog text. And lastly, a boolean called entry point. We're gonna use it as a start point. Then let's jump into the dialog graph view class and create a constructor. To add drag and drop mouse selection features, we just need to add few manipulators to our graph. Let's add a content dragger, a selection dragger, and a rectangular selection. Awesome. Now let's go back to dialog graph class and create a static method to open up the graph window with the following lines. And let's add a menu item attribute on top of it to be able to actually call it statically from the editor. In case you don't know, a method can be called as a menu item using this attribute. But this is only possible if the method is static. That's why we are marking it as a static method. With that being said, let's go back to Unity. And now we can see our dialog graph window. Great, but sadly we can't do any dragging and stuff because we haven't added the graph view into the editor window yet. We just see the editor window, but the graph view is not there. So let's go back to writer and let's implement it. In the dialog graph class, let's add onEnable and onDisable methods. Then let's create a private variable and call it as GraphView. Those methods are just like Unity's start and destroy methods in regular Unity classes, which means in onEnable method, we need to get a new instance of the graph view and store it into that variable just we have created. Okay, while getting the instance of this graph view, as in the constructor, I'm gonna pass the name of the graph, and then I want to stretch the graph view all over the editor window. Then finally, we need to actually add it to the editor window with root visual element.add method. Lastly, we need to remove it when this window is disabled. This way, graph view will not gonna overlap if we constantly open up and close the graph down. Nice. Let's go back to Unity and try it again. Now, as you can see, I can click and drag my mouse to make rectangle selections. But to actually do the drag and drop, we need to have nodes, right? Yep, that's correct. Now, let's go back to dialog graph view class and generate our first node. Let's create a method called generate entry point node and start by getting a new instance of the dialog node. Okay, now I want to pass few variables into it. So I'm gonna name the node's title as start because this will be our entry point node. Then GUID, as you might remember from the node class, I'm gonna generate a new GUID with C#'s default GUID class. And then I want to pass the entry point as the dialog text. Though we are not gonna use it, so you're free to name it as banana if you like to. Lastly, I'll mark this as entry point node, so I will pass true for this boolean. Alright, with that, now we have a node instance. So we need to set its position and add it to the graph view because it's not yet added. Let's set its position as follows. Then we're gonna make this method return the node after doing that. Then in the constructor, we need to actually add it to graph view using add element method. This method is inherited from the graph view base class, in case you're curious about it. Then let's go back to Unity, and voila! Okay, now let's add a few ports to make connections between other nodes. Let's go back to code and create a new method called generate port. And we're gonna return the instantiated port, then get few parameters into it. First and foremost, we need to pass the target node as a parameter to actually spawn this port into this node. Then we're gonna need the direction info, like it is gonna be an input or the output port. Then finally, we're gonna need to get the capacity, which means, is that gonna be a single connection accepted node, or are we gonna able to connect multiple nodes into that port? So that's where we decide about it with the capacity. After that, we're just gonna return node instantiate port method with those given parameters as follows. For the type parameter, you can pass any random type if you wish. I'm just gonna pass float. The reason this is an arbitrary one is because we're not gonna transmit any data between ports. But this is especially useful for things like shader graph or VFX graph. Like you're gonna get the texture, and using this port, you do something with that one. But in our case, we don't do it. We just check the connections and move forward. Cool. Now let's call this in our entry point generation method. First of all, we're gonna pass the node because we wanna do that in the node, and then we will set the direction as output because we're gonna wanna jump to the first connected node. Then we're gonna assign this port into a variable, and we're gonna change the port name to next. Port names might not seem important now, but when we start saving those nodes, they will be crucial for us. Then, as we usually do, we're gonna add this port into the node, and we're gonna need to do that addition into the output container as follows. Great, let's go back to Unity. Now we have our output port. We can drag it over and have fun a bit. Also, we can drag the node, as you might notice. But there's something strange, isn't it? In the left-hand side, the node is looking a little weird. This is because we haven't updated the visual look of the node. We just added it, but we didn't request a refresh on the overall visual. So to fix it, let's jump back to writer for a sec. Then let's call node.refresh expanded state and node.refresh ports. So we're gonna need to call those methods after adding a port into the output container. Same applies if we do something else with the containers. Then when we go back to the Unity, this weird artifact will disappear now, which means we can put everything into gear 11. Let's quickly jump into the dialog graph class and add a method called construct graph. Then I'm gonna move my stuff from onEnable to this method to reduce the clutter, because we're gonna add a toolbar for creating new nodes. To do so, let's create another method and call it as generate toolbar. First of all, we're gonna need to get an instance of the toolbar. Again, it is all provided by Unity by default. After adding that, we're gonna need to add a button into the toolbar for triggering the node creation. And I'm gonna pass a lambda expression to actually write down the logic of the button click. What I would like to do is I want to use our GraphView variable and call create dialog node method, which we will create in a moment. Then, just like what we do with all the other UI elements, we're going to add that button into the toolbar. Finally, we need to add the toolbar into the editor window. Okay, then I'm quickly creating a method inside of the dialog GraphView class. In here, we will actually create our dialog nodes. First of all, let's change the return type into dialog node and add an input parameter called node name as a string. Then, just like what we have done with the entry point node, we're gonna get a new instance of the dialog node. This time, we're gonna pass different titles, which we get from the node name parameter of this method. Also, we're going to pass the same string to the dialog text for now. And don't forget that we're going to need to create a new unique ID for this new node. Cool. Now let's add some ports. First things first, let's add an input port using generate port method and pass the direction as input this time. Also, this time we want to pass the capacity parameter as multiple, because we want branching to other nodes and let them connected to the input port of a single node. Then we can add this input port into the input container. Also, let's not forget that we need to update our node's visual after modifying the port. So I'm gonna pass the same methods for this one and set its position. As for the node scales, I'm going to create a little variable that will be used as a preset. Since we're not intended to modify it on the runtime, I'm going to mark it as read-only and call it as default node size. Then let's jump back and pass this as a parameter for the position declaration. Now we can finally return the node. Cool. Let's go back to the dialog graph class where we call this method and pass the node name as dialog node. Oops. As I've forgotten here, we need to call this toolbar method from onEnable, because right now it's not called from anywhere. Thus, it's not going to draw anything if we don't call it, right? Okay, so we need to make a little addition here. We don't want to actually call the node creation method from this part. Instead, we also want to add this node into GraphView, because we haven't done that yet from anywhere. To do so, I will create another method called createNode, and using addElement method to add the created node into the GraphView. Now if we go back to Graph and Unity, we can finally add new nodes together. Yes, but as you might notice, when I start dragging the entry point port, other nodes' input ports get blacked out. This is because we haven't defined which types will be accepted as inputs. So this is useful if you have data that you pass into the node, like the shader graph, as I said before. But in here, we don't need that. We can get any different data types. We just look for connections. To fix this, let's go back to GraphView script and override a method called getCompatiblePorts. Then inside of it, I'll create a new list as compatible ports. As a following operation, I'm going to use a property from the base class called ports. And using that, I will iterate over all the ports to see which ones are okay to be connected. To do so, first things first, we don't want to connect a port to itself. That would be funny. Then, as a second rule, we don't want to connect the input port of a node to its own output port. That would create infinite loop, which is weird and probably cause problems, so we should not allow that. So let's use those rules as follows with the for each statement. Okay, if those conditions do met, we can add it to the accepted ports list, and we can return that list at the end of the method. Now let's go back to Unity and add a node. Now as you can see, we can connect them together. Great! This means we can add output ports and complete the first sketch of our dialog graph. Let's go back to our createDialog method. This time we want to add a button for adding infinite amount of branches. So I'm going to create a button and pass a lambda expression as addChoicePort. Then I'll create that method at the bottom. First of all, we're going to need to generate a port like we did before, but we're going to pass direction as output and keep the capacity as single by default. Then we want to change the port name for each and every option. To change the port names for each new choice, I'll search for all the ports in the output container of this node, and then I'm going to assign the port name as choice port count. Then finally, I'm going to add this port into output container and refresh the node visual just like before. Now if we go back to Unity, we don't see a button. Why? Because we haven't added it to node. Alright, let's go back and do it. Okay, I'll add this into the top side of the node, which is called title container. And let's add a text for the button as new choice. Now, let's try it again. Awesome! Now we can add crazy amount of ports to our node and connect new nodes to each other. Alright, we're almost done with the first episode, but as you might notice, we can't zoom out since we haven't added it yet. But worry not, it's deadly easy to add. Let's go back to our GraphView class, and in the constructor, let's say setup zoom, content zoomer default min scale, and content zoomer default max scale. No, I'm not joking, it's that simple. Now let's go back to graph. Finally, we are able to zoom out too, and we have a fully functional graph. But we can do better, right? Let's add a grid background before ending the video. To do so, Unity provides that one too by default, but we still need to do some tweaks for the colors of the lines at the background. To add it, let's just get a new instance of grid background and insert it as the background of the graph view. Then I want it to be stretched all over the screen at the background. Okay, background color has changed, but we see no grid. This is because we need to add a style sheet and change grid line colors. The grid lines and the colors are there, but they're in the same color, so we need to change them. I don't know why this is the case, but that's how it is. So let's go to the project window, create a resources folder, and right click on Create UI Elements Editor window. Okay, in this little pop-up, we don't need any XML or C# script, but we need a USS style sheet. So let's keep it checked and call it as dialog graph. Then let's double click on it to open it up. Then we can get rid of the default content because we're gonna define what we want to show. Now we're gonna need to say to Unity that we need to change the grid background's visual properties. Well, those are hard-coded USS statements, so you don't have to understand them. You can just follow what I wrote here. But the only thing that you need to know is it changes the line colors. So it's pretty obvious once you understand what it does when you look at the processors. So I'm going to pass those values for colors. Finally, we need to load that style sheet with the resources load and add it to the style sheets in the constructor method. Then if we go back to graph, we can see the grids nicely. With that being said, we finally have a fully functional graph. In the next episode, we're gonna make it savable and we're gonna add more colors and make it fancier. And don't forget the dialog text. We haven't added that yet, but we're gonna do that. Okay, that's all for this episode. But in the next episode, we're gonna finalize it. As I mentioned, we're gonna add the dialog text and we're gonna play with the colors and we're gonna save the nodes. Right now we are displaying them, we are creating new nodes and connecting them, but there's no saving applied. So we're gonna get the node data and then we're gonna use the GUID and stuff like that to actually achieve the saving. And that's basically it. I hope you like this kind of coding tutorials. I generally make shader tutorials, I know that, but I couldn't resist to make a node-based dialog system tutorial since there's no such a thing in anywhere in the community. Like there are basically very few people are using this API, but it is embedded into the Unity and it's not going to be removed or stuff because it is being used in the shader graph and the VFX graph. So we are safe here. Okay, with that being said, we're done with this video. And if you like this video, please press the like button. And if you want to see more videos like that and see the next episode, please consider to be a subscriber to my channel. It's really important. So that's all for this one, and I'll see you in the next video.